Hi everyone, wanted to do a really quick little video here regarding inductance on the Orbo motor here. As you can see, I've got a lot more coils than I used to have. Only had 4 before, now I've got 6, and they're double wound, meaning bi-feeler windings, but that's well, it becomes important if I decide to wire the individual coils in series adding by feeler mode, which they are currently not. Right now I'm using the second windings kind of as an inductive generator kind of secondaries, and the first winding or one winding would be the drive coils running the motor. So I just decided to make an inductance measurement to see how much inductance I have with 6 coils. 7.1 Henrys. If you can see the decimal there, it's about 7.1, which is very high for very small coils. I went to an online coil coil calculator, and I had to type in ridiculous amounts of winds, like 5,000, 10,000 winds, just to not even, and it doesn't even break the 1 Henry mark. We have 10 here, or sorry, 7 here. Now the other thing I wanted to show was that right now the rotor's static. It's not moving. This is what we get for inductance. Now watch what happens when I spin the rotor. The inductance goes nearly double. Now isn't that interesting? Some sort of variable inductance happening because of the magnets moving past the cores. Now I hope Ed or Doug might be able to shed a little bit of light on that. I know I've seen some YouTube videos of guys showing some variable inductance type of phenomenon going on with certain types of coils, but I'm not sure that I've ever seen anybody demonstrate it with with the Orbo and the Torroids, although that it's very possible that that's kind of where I got the whole the whole notion in the first place. But we stopped the rotor, and of course our inductance goes back. It's actually lower than what it was before, but we're on the 20 Henry scale, which isn't really a very accurate scale to begin with. If we put it on the 2 Henry scale, it's a finer scale, but obviously we have far more inductance than 2 Henrys. So we have to go with best guess that the meter can do on the 20 scale, which is about 7 roughly. And there again, spin that rotor up, and our inductance increases dramatically. So maybe some of you thinkers out there can figure that one out, because I'm not a I'm not a whiz when it comes to the real nuts and bolts of electricity. I mean, I can do the basics, but and I can fix lots of electronic gadgets, but understanding the real raw physics of it is another thing, probably because I agree with Tom Bearden when he says that our electrodynamics model is severely lacking, terribly inadequate. So there's a lot of shit we don't understand because like Tom says, the electrodynamics model has been, you know, trimmed down, so to speak, to kind of, you know, cater to the kind of electronics that we've you know, that we build these days, right? It's extremely inefficient. You know, there's no free energy to be had anywhere in any of the devices that we build, simply because we just don't build them correctly according to a proper electrodynamics model. I totally agree with him on that. And I'm sure lots of other people do as well. But anyways, I think that'll be it for now. I want to keep this short. Sayonara.